Okay. The 1.2 functions. So remember, any function is a relation. Any set of orders, so vocabulary. So it's any set of ordered pairs that satisfies some rule of correspondence. So it's just a definition. Um, so for example, you have the coordinate 2, comma 3. This will satisfy the following equation. Y is equal to x plus 3, or sorry, x plus 1. If you plug in that coordinate into that function, it has to hold true if it is a relation. So remember, x is 2, y is 3, so you just plug it in. 2 plus 1, 3. So this holds true. So that order pair satisfies that equation, y equals x plus 1, in general terms. The next important term that you need to know is a function. A function is any relation where each element of domain is paired exactly with one y coordinate. So here's an example in terms of what a graph will look like of a function and not a function. So let's say you have a graph like this, and you had a line going through it this way. This is a function. Every x coordinate has one y coordinate. An example of not a function, x, y. So you used to have something like this. I know you're just looking at it, you know that this cannot be a function because there's multiple x coordinates that have more than one y coordinate. And what you learned in Math 1, you could actually apply the vertical line test to determine if a graph is a function or not. And if it hits the graph more than one time, which in this case here and here, it is not a function. Usually, if you either use your finger or use you use your pencil and just hover the actual graph. So remember, for domain is the set of x coordinates. So the set or x coordinates of a relation. Then you have the range, which is the set of y coordinates. So for example, let's say you have a set of coordinates. So you have the following 0, 1, 2, 3, 4, 6, -12, -1. And you're asked to determine the domain. Well, the domain are all the x coordinates 0, 2, 4, -12, while the range would be 1, 3, 6, and -1. Does anyone have any questions? Okay, so now we get to the tricky part. When finding domain and range, you have to be careful of radicals and rational functions. So when finding domain and range, be careful with radicals and rational functions. Okay, do you guys know what the rule is for radicals? There's one turn rule you gotta always know about radicals. You guys know what it is? What's the one thing you gotta be careful when you're doing radicals? It's not. Very good. Make sure, oh, sorry. Cannot take square root of negative number. Doesn't exist. And then what about for rationals? Do you guys remember what the rule is for rationals? Denominator cannot equal 0 because then you'll get undefined. So for now, we're just gonna take into account the domain for the following problem. So is everyone good? Does everyone have this one down? You guys good? So then we'll do a couple problems regarding finding the domain of different functions. Okay, so here's the following examples. Find the domain of the following function. So you have the function g of x is equal to 1 minus 2x squared. So this is just a regular parabola. And what is the domain of this function? Can you guys tell me? Does this have a restriction? No, right? So then what do we call a function when it comes to finding the domain when there is no restriction? You guys remember what's called? So remember, the domain is what number we can input, right? What numbers can we input into this function? Any number, right? So what do you call it when you can plug in any number into the function?
I don't know, the like, negative infinity and positive infinity.
Very good. So negative infinity to positive infinity. This is the same thing as saying all real numbers. This function has no restriction in terms of input. And that's where you're gonna have to be very, very careful when you're doing the homework problems because it makes you might be given like funny looking functions, but the only thing you have to look for is does it have any restrictions in terms of it's not a radical and it's not a rational either. So there is no restriction. So if there is no restriction in terms of your function, you can actually plug in any number and you'll always get an output. So then your answer is this is just all real numbers. And you could just say all real numbers are do the negative infinity to positive infinity. The other notation that you'll see is the R. Like this, that also means all real numbers. Let's do another example. Um, S to the Y is equal to 3Y over Y plus 5. What would the domain for this function be in this case? Very good. So because this is a fraction, this is a rational, or you could just say fraction. Honestly, whichever one makes you know that's a, can't have zero in the denominator is fine with me. So you know that you can't have zero in the denominator. And honestly, if you want to figure out what the number is equal to, you could just take the denominator, set it equal to 0, and you'll be able to determine what the number cannot be. So all real numbers except y equals -5. Because -5 will make my function undefined. Or you could also just say y can't equal -5. That's honestly the same thing. Because you're given the restriction that y can be any number except -5. Okay, we'll do another one. H of x is equal to 10 over x squared minus 2x. What about this one? How would you find the domain for this function? What do you think you'd have to do? So I'll give you a hint in the previous problem, but it's not enough to solve for it. Yes. Yes. Very good. So you set the denominator equal to 0. So x squared minus 2x equals 0. In this case, you're gonna factor. Or technically you don't, but it's always good to whenever time you have a exponent greater than 1 to factor. So in this case, x squared minus 2x factors to what? You guys know? X parentheses x minus 2, right? Because I could factor in x. And then the zero product property, because you equal it to 0. X equals 0. And then this is x minus 2 equals 0. This is already solved. So x cannot equal 0. But for the other factor, x cannot equal +2. So the domain for this function can be any number except for 0 or +2 because plug in either of those values will make my function undefined. So all real numbers except x is equal to 0 and x equals to 2. So in this case, you're gonna have to do the zero product property. Okay, we're almost done. Two more. Okay, so here's the tricky one. You have g of y is equal to y plus 2 over the square root of y minus 10. What do you think you'd have to do for this one? Because now you're stuck with one, it's a radical, and then two, it's also a rational function. Question, yes.
One thing I'm pretty sure about this is that it cannot equal anything negative because it's the radical.
Okay, that's true.
I'm blanking on the rest because radicals remind me.
So you're right, it can't be negative no matter what. But what's another point you can point out, Elijah? Okay, so then how would you write that for the domain? Fortunately not. Uh 11 to infinity, you're kind of close. You're kind of close. You're missing something though. Yes.
Would it be all square roots?
No,
Okay.
no. You're super close, Elijah. It's actually 10 to infinity.
Um,
10 greater than, oh, sorry. Y is greater than 10. So any number greater than 10, meaning Elijah, can I plug in 10.1 into my equation? Right? Because if I plug in 10.1 into my equation, I'll get 10.1 minus 10, right? And that'll give me a positive 0.1. And can you take the square root of 0.1? You can, right? So you're really close, but it's actually 10. Y is greater than 10 or 10 and comma positive infinity. Does anyone have any other questions, right? Because what would make the equation 0 in the denominator? 10, right? Because if I plug in 10, 10 minus 10 is 0, then you can take the square root of 0, right? But well, when you simplify it, you have 0 in the denominator, which you cannot have. So that means my answer can be anything but 10. Okay. What's another thing you could have done? No, okay. Last problem, and then we're done. F of x is equal to the square root of x plus 2. What would the domain for this one be? So if you're given a radical, you can always find the domain by taking whatever's inside the radical and setting it equal to 0. And then just solve for x. So that means x has to be greater than or equal to -2. Or in this case, you can write it as bracket -2, infinity. That bracket on the left-hand side of the -2 means it can actually be -2. If you have a parentheses, that means it's close to that value, but will never hit that value. So you got to include the bracket when it's greater than or equal to. You lose the bracket when it's in the rational, so do be careful. When it's in the rational radical, you lose the bracket and you lose the equal sign, and it's only greater than. So do be very careful. And if it helps, you can make a table too. So you just gotta make sure you include every value. Okay, the last thing you guys are gonna learn is just solving for input functions. So g of x, 1 over x squared minus 9. And then you're gonna solve for different parts. So the first one is g of 2. So that means you're just gonna plug in g is equal to 2 into your function. So 1 over 2 squared minus 9, and then just solve it regularly. -5. I put +5 in the notes. Gotta make sure I fix that. So 1 over -5. Or did I include it? No, I think I messed up. I didn't put negative. And then just another one. G of 3. When g is equal to 3. When you get 1 over 0, do not make the mistake. I always have a lot of students make this mistake, especially when it comes to the quiz or the test. If you write 1 over 0 and say 0, that is incorrect. This is considered undefined as your actual solution. So do not make the mistake of writing 0 because 1 over 0, even if you plug it into the calculator, it'll give you an error. So that just means undefined question.
Are we allowed to write an error?
Sure, as long as you don't write 0, that's even worse.
I'm saying that means because we don't know.
Yeah, that's undefined. Okay, the last one is always a tricky one too. You guys gotta be able to know how to simplify more than one term. So g of y plus 3. So that means you're gonna plug in, when you plug in the equation, g is equal to y plus 3. So all you gotta do is just plug it in. The only thing you have to be careful is when you simplify. Y plus 3 squared minus 9. Okay, what is y plus 3 squared simplify to? Or matter of fact, what does that square tell me about the y plus 3? What does it tell me? You guys know? Elijah?
Y plus 3 times y.
Very good. I have students make this mistake of distributing the 2 and giving me y squared plus 9. This is incorrect. So remember, y plus 3 squared means that there's 2 of them. Y plus 3, y plus 3, minus 9. So I'm going over some common mistakes that I've seen students make when doing these problems. So do be careful. So you just use distribution property, y squared plus 3y plus 3y plus 9. Combine line terms, y squared plus 9y plus 9 minus 9. Simplify it, y squared plus 9y, because positive 9 and negative 9 ended up, and I made a mistake. This should not be 9, it should be 6. I multiplied instead of adding. 3y plus 3y is 6y. So then when you simplify it, you should have 1 over y squared plus 6y as the solution to the problem. Does anyone have any questions? Other than that, that's it. That is today's lesson. Just domain and range is a function, not a function, and being able to input values and then simplifying your function. So pretty easy, not too hard.